All right, welcome back. I hope you're having an amazing time so far. Our next panel is titled The Rise of Enterprise AI Platforms. Please join me in welcoming our panelists to the virtual stage. And I'll hand it over to Arya, our moderator.
Great, thank you so much. Hi, everybody. Very excited to be here. Thanks so much for joining us. We've got a great panel lined up for you, but no good discussion is it's going to be good without proper introductions. So with that, I'm going to go ahead and pass it off to first to Nikon, who will introduce himself, and we'll end up with me before we go.
Hi, I'm Nikon Rasumov. I'm the PM lead for AI data and feature engineering at Facebook. Thank you very much for inviting me. Just to be clear, all of the ideas I'm sharing here today just represent my ideas and not my employer. Prior to Facebook, I was a PhD in computational neuroscience, and for the last 10 years, I was a product manager, mainly focused on machine learning and cybersecurity. I worked in Symantec cyber insurance vertical. I worked in Cloudflare and developed one of the biggest machine learning deployments in the world, 15 million operations per second. At Alexa Voice Shopping, I was responsible for privacy and security. Thank you again.
Wonderful, thank you so much. Rahul, why don't we go with you?
Hi, thanks, Arya. Pleasure to be here. Rahul Singhal, Chief Product and Marketing Officer for Innodata. Innodata is a leading data engineering AI ML firm headquartered out in New Jersey. We create training data for data scientists to make AI real. Excited to be here. Prior to Innodata, I spent a lot of my career at IBM, started my AI journey leading products at Watson, commercializing the NLP vision, speech and data products. And then after Watson, spent 2 years doing a startup and leading unstructured data and personalization around marketing platform called Lucy.ai. So pleasure to be here.
Wonderful, thank you. And last but not least, Daniel.
Hi, everyone. Very happy to be here. I'm Daniel Romine. I'm a senior applied scientist at Amazon. I'm currently working at Amazon Photos. I have previously worked as leading a machine learning team at Adobe and working in aerospace at Boeing and data analysis at NASA. I have a PhD in mathematics. I have experience in a number of product applications, especially in computer vision, natural language processing, ranking and curation, and looking forward to everything we're going to discuss.
Excellent, thank you very much. And well, I guess another last but not least, I'm Arya Eskamani, Director of Global Data Science at Visa. It's everywhere you want to be. Probably so big, we're also everywhere you don't want to be, but still. I've been doing data science for about 10 years. Most of my work has been in time series, natural language processing, led some computer vision teams. And apart from that, again, thank you all very much for joining us. I think we're going to go ahead now and get started with our very first topic here, first question for the panel. Okay, let me sort of tee this up for everyone a little bit. So we're all here because we found or made some success in artificial intelligence, and AI has, it has shown that it can generate some value. We've seen some very exciting technologies such as autonomous vehicles, personal voice assistants, and let's see, Visa, for example, we estimate that about $25 billion a year is saved due to our AI contributions in the world of fraud detection. However, AI can also be very troublesome to implement. I caught an article this weekend, for example, that published in the British Medical Journal, this was last year. This research looked at over 230 predictive models for COVID, and only found that none of them were good enough for clinical use. Only 2 of them were good enough to even be useful for any future research. There was a similar study also out of the University of Cambridge for deep learning models. I think they looked at 400 models, same conclusion. So for the panel, while AI has shown tremendous value, why can it be so hard to implement? And just in the interest of precedent, let's just go with Nikon first as TSF.
Yeah, I can kind of provide my perspective on this. I think it's a there is an evolution going on machine learning. And kind of the first problem that was occurring was that the business leaders had a problem they wanted to solve, and they were having really big difficulties communicating to the machine learning engineers and developers what the problem is. And I think that problem maybe even still continues to happen in smaller companies. Bigger companies have really figured this part out already. The second step of that evolution is, once you have identified the problem, you really need to produce something that is actually working. Like, you focus really on performance, ROC, ROC curve, F1, all of these metrics. And then you like hammer out the performance to a certain business acceptable level. The third level of this problem is then you need to hand over that algorithm that you developed at home and hand it over to your friends, the scaling engineers, the production level engineers, to deploy this algorithm. And I've seen the terrible things happening. Like at Semantic, one of our machine learning engineers just brought his Python code and said like, hey, good luck, deploy this, right? That obviously doesn't work. And then the fourth level of this is, once you deployed it, a lot of magical things start happening. Like your customers keeps asking you, why have you rejected my loan application? A lot of need for explainability is arising. The fifth level of this is, 2016 election happened. A lot of people had privacy on their mind, and privacy is obviously a big issue, right? You have technologies like federated learning or differential privacy that can address that, but it's a really, really hard topic to address, especially for the users. And then the last level is the fairness development. Like, when you develop an algorithm, is it fair? Fairness is an incredibly complicated topic. I'm not going to do it justice here, right? There is a question about equity, about transparency, but there are also some very simple low-hanging fruits. Like, do you have an equal distributions of both genders in your data set? And I think if I was to summarize the steps of evolution, I would say it all really comes down to machine learning experience. And by that, I don't mean the user experience where you just press buttons and you get something out, or developer experience where you have nice APIs, but really just the machine learning experience of all the stakeholders that participate in developing machine learning. That is the thing that is really stopping everyone right now.
Okay, touched on a lot of really interesting points there. I'm personally, not to hopefully steal thunder away from anyone else, but I'm personally a big fan of the very last thing you said, sort of keeping everybody sort of connected, bringing these AI folks sort of into the room. And it's also it connects to the first thing you said. It's like business stakeholders are going to make some recommendations or these plans, and then it gets lost in translation, and all of a sudden something comes out that doesn't meet the individual goals of what was originally stated. Lots of cool topics there. Hopefully you left something for someone else to pick up on. Rahul, what do you think?
Yeah, I agree with Nikon on most of the topics. I'll take a different perspective on it. I will take it upstream. A lot of the, I'll start by a quote that I love from, I don't love, but it's true. The chairman and CEO of IBM, Arvind Krishna, he publicly came out 2 years ago saying 80% of IBM projects are failing for lack of data or lack of training data, right? And we see that over and over again. Is, I think, a lot of the times where I have seen, and a lot of our clients have seen, AI, when you think of the journey 8 years ago, 10 years ago, when we started really deploying AI, it was interesting, right? It was more of a research project, and companies started to dabble in it with saying, hey, it's a magical black box. You put data scientists on it, and they will basically create an algorithm which will solve which will come back with answers, right? As the technology has matured, it's come back to the age-old problem: garbage in, garbage out. You really need high-quality data that could be fed to the machines that are then analyzing it, and all the points that Nikon mentioned about transparency, fairness, starts to matter, right? So, to give you a few examples, we work with one of the largest machine learning companies in the world, where we are training models on training models for all the way from object detection to NLP, where we're looking to train models for entity recognition and named entity relationship mapping around healthcare data, right? Now, to be able to create pristine data sets, you need deep domain expertise that can annotate that data, and then can do it in a manner that can that can be trained. Today, most of the companies don't have a pool of staff that can actually do it, because that's hard work. It requires a lot of cleaning, a lot of normalization of the data, and then requires you to have large experts who are willing to spend their time. And data scientists don't want to spend the time annotating the data. I mean, the reality is data scientists want to be building the model. That's where we find a lot of data scientists don't want to spend hours and hours cleaning and annotating 100,000 records. So I think lack of subject matter expertise and data engineering tends to be a big hurdle in really creating high quality training models, which is getting down to how you would implement an ERP solution. If I go back 20 years, I'm aging myself. I think AI is at the cusp of require similar kind of diligence, where it's driven from the top. The CIOs or the product leaders really think of it as a long-term journey, not like a 3-month where you're going to get a bang for a buck in 3 months.
Got it. Okay. All good points. Thank you so much. So we talked on some organizational challenges, we talked on some scalability challenges, and now some talent and data cleaning challenges. Daniel, anything to add?
Yeah, absolutely. Some very strong points that have been brought up thus far, especially around fairness, transparency, and a lot of the risk that comes into play when releasing a model to production. So models operate, to add on that point a little bit. So models are essentially statistical beasts. So they are not like algorithms that are much more rule-based, where you have control over every outcome. You're looking at covering as many of cases as reasonably as you can, and there's often a lot more risk that comes into place when you're releasing models to customers. And what's important is to think about, really, in addition to just much more software engineering traditional train of thoughts around SLAs, for example, and considerations like that. You have to think about the risks that are involved in exposing a statistical algorithm to your customers, and account for the fact that with any statistical algorithm, to an extent, you're going to have bad experiences that are produced from that. And the goal of the machine learning scientists is to reduce the amount of bad experiences that happen. However, there's always going to be a perhaps shrinking but still present percentage of customer experiences which are ultimately either bad or in some cases downright hurtful and offensive. So part of the product design consideration process that goes into planning around machine learning for customer experiences is you have to be aware of this risk. You have to build in mitigations of this risk. You have to do things like you have to build in feedback mechanisms where you can get response from your customers on those failure cases, both for being aware of what the issues are so that you can continue to work on them, or in other cases, those feedback mechanisms can actually be direct inputs to your data pool that you can turn around and continue to train new models off of, towards the goal of continual improvement of your models via online training or continual training and paradigms like that. So some other considerations, taking another perspective on some of why AI can be so difficult as well, is in addition to a more of what I would describe as a one-off mindset that a lot of ML teams, when they're first started within an organization, they're thinking much more in terms of one-off projects. So I'm a new team, we need to show off our merit and our value to the company. So we really want to pour as much as we can into this one-off model and really give it good quality, good value, make sure that we're demonstrating ourselves for the company. However, the problem that arises as this new AI team within a company continues to grow and continues to mature is you realize that one-off models are really not the reality that you have to be thinking of long-term. You have to be thinking of your long-term operational costs that are going into this. And this takes into account certain considerations such as individual models can often introduce technical debt into your system that are important to be aware of. So for example, what are the dependencies for your model? Are your dependencies going to be often changing? Are those changes going to be something that you can account for just by monitoring the inflow of data and maybe raising a flag whenever you have sufficient domain shift of one of your input variables? Or in a much more taxing situation, when you have domain shift, does this mean that you have to go and pull off one of your very limited pool of scientists to go and retrain a new model, revalidate a new model, perhaps even gather new data? All this churn can be very time consuming. And what operationally is often observed in my experience is that these ML projects can be such long-term investments that you want to really cut down on the operational cost as much as possible. On the other side of operational cost is you also look at just your project-to-project operations and how you can not have every project be consumed by very time-consuming operations such as data engineering, data cleansing, data validations. When you repeat a project, there's a whole lot that can be discussed in terms of data provenance, so knowing exactly where your data came from, having pipelines in place that you can reproduce the process.
So do you mind real quickly if I stop, just only because you're picking up on our next set of questions, and I think this will be a good segue, and I'm gonna kick it right back to you, though, I promise. We got two questions next. They're actually very related. I'm also hearing a lot of things about tools and procedures could mitigate, like you said it, Daniel, like there's a sort of risk you got to mitigate, and then there's the point that can't go away. And a lot of the solutions other folks talking about I think I'm hearing mitigations in terms of better tools, which is this question. And then the next one, we also have something on procedures. So just kicking it back to you, Daniel. You talk about, you were just going to some procedures that seem to mitigate some of the risks you're talking about. Are there any tools also you can add that could be good to mitigate some of this risk or make your app production more successful?
Yeah, absolutely. So if I were to bin some of the largest risks you encounter in typical machine learning projects into two broad categories. One is product risk. So ultimately, what is the customer experiencing through what you introduce? And that really needs considerations at the product design level to make sure that you have mitigations in place and account for those inevitable small percentage of failed experiences. In terms of the other large risk, it's the operational cost of how much it takes to the time cost and the dollar cost of your ML engineers, your ML scientists for taking model development time from many months down to as small of a turnaround cycle as you can produce that. For the latter set of problems, there's been maturing in the ML industry over the past few years, a pretty rich ecosystem of tools that are specifically designed towards tackling and chipping away at a lot of those problems. So just to list a few, there for data provenance, there is data version control, and there is ML flow, which is a host of multiple different capabilities. And there's Pachyderm and quite a few others that could be listed, but one that I'd really like to mention, and perhaps I'll save going into detail for follow-up questions, but one ML training ecosystem that has been building out a lot of capability chipping away at multiple of these problems has been AWS SageMaker. And in particular, AWS SageMaker started out as an IDE for a cloud-based IDE for training models, but in the past year plus, especially, it's released a lot of new features that are really building out a quite broadly robust ecosystem for training, which is introducing a lot of capability to new ML teams.
Awesome, wonderful. Thanks so much. Nikon, any tools and procedures you think folks should take note of to be successful in their AI production?
Yeah, I find this discussion really interesting. I think both Daniel and Rahul mentioned data, and I think there is an entire class of products out there that is kind of data-first startups. I can name a few, but Auto AI, for example, is looking into the bias of data. Supervised AI is looking at the drift. And I think one of the interesting things, when you start looking at the original data, like the features, you can detect a data drift or like changes in production performance before the model starts underperforming. You can already see there was a change in the shift and distribution. Like imagine like that, 30 months, it takes 30 days to see that somebody is going to default on a loan application. But in the data, you can already see it. You don't need to wait for them to default on the application. And so you save 30 days. Another cool thing I recently saw, and maybe Rahul can talk more about it, LandAI has started a competition, a data competition. It's the first machine learning data competition where you have a fixed machine learning algorithm and everyone can suggest their data sets and enhanced data sets, clean data sets. And I completely agree. This is kind of a game changer for our industry. So there is this class of companies that are doing data first. I really love that. And then the second class of things that I already kind of alluded to is machine learning experience first. I think that is really the trick. Like, for example, no code companies like Obviously AI, right? So they have participants that just do machine learning. Data Robot is another one of those players. The only thing I would like to kind of emphasize is that it doesn't necessarily need to be a UI solution. It doesn't necessarily need to be a no-code solution. Machine learning experience can also be a beautiful API, beautiful documentation, beautiful code. Like PyTorch, for example, is a good example in that, right? So it's very widely adopted and it doesn't have a UI.
Wonderful. Rahul, take it away, man. What do you think?
Yeah, I mean, I think the journey of tools goes all the way from starting to cleanse the tools, right? Cleanse the data. And there are lots of companies doing some really interesting stuff. We built a data annotation platform around image, video, text, where you need, what we find is that the one size fit all doesn't work, and you need very different variety of workbenches that solve a problem for a contract versus we work for credit card transactions, right? That's a very different kind of a tooling required to do the annotation versus looking at healthcare data, which requires HIPAA compliance versus legal documents, right? So when you start looking at the variety of different document types, you need different tooling. And open source tools like, say, Brecht and Prodigy and other open source annotation tools don't work. Then you start getting into the actual data science side, and then obviously there are tooling required. Yeah, we've used SageMaker, which we love. Daniel, I think it's a fantastic ecosystem of tools that going in the direction of AutoML. I think they've come a long way. We've used Google, we've used IBM Watson Studio, which I think is really interesting. And then some other startups which we have found who are doing some really interesting stuff around ML ops. Weights and biases is a new one, which has come around managing taxonomies and being able to manage your algorithms in one place with all the challenges around data drift to ensure that the model is fitted to the right the model updates with the data drift and changing model. And then I think what I find really lacking from a production purpose is a tooling that is a review tooling. So when all the models are going, but how are you ensuring that there is the right tooling to review the data and someone is looking at it and doing the retroactive feedback mechanism to ensure that fits back? And I find a lot of companies, and I'd love Nikon's and Daniel's perspective on that, as how you have seen that problem solved. I find that companies haven't thought about it, and it's very nascent today. And that seems to be a big pain point, is how do you ensure that you have the retroactive feedback mechanism and the tooling with a really good experience that integrates into your production application and is able to do the feedback?
Yeah, to add to that, I find what's a good complement to that is also, I mean, I understand it can be difficult depending on the models, but AI explainability, I think being able to also translate back to your stakeholders or yourself or as part of some review process why a model made a decision is going to be more important. I know it's difficult. The closest thing I've seen that seems to touch on this problem in a really good way is our SHAP scores. They've technically been around since 2016, but I've been hearing more and more about it recently. We recently created sort of a model framework at Visa that utilizes them because we sometimes have to explain why models make decisions. Very cool, awesome. Let's move on to procedures, and I'll just kick it off with sort of a personal thought, and I'll let you guys decide whether or not you agree with me or not, and if you think anything else is good to throw in here. In terms of procedures and structure, I've kind of seen multiple companies try different things. There's sort of a consultants only approach, sort of an internal consultant approach. We got this small team of DS folks, and oh, that's right, that's our next question. You got a small team of DS folks that are sort of embedded by themselves, and they're kind of farmed out. They're kind of farmed out to different teams, internal consultants, kind of small group. Then you have sort of a hub and spoke or a center of excellence model where, okay, we got a core team, all the learnings are kept inside, and they're again similarly sort of farmed out to other teams to apply their expertise, but all that knowledge is sort of refined in-house. And then you sort of have this embedded team approach where everybody gets their own data science team. And for me, I think I've seen it's just not scalable, loss of standardization, things like that. So then sort of staying on that question, is there structure, do you think that works? And to sort of also add in, do you think there's a better structure works with that sort of works better than others? And where do you see sort of data engineering and DevOps fitting into that structure? Let's see, let's go back to Daniel.
Great, thank you. Yeah, I think there's a lot of viability in the different options that you've mentioned. And in particular, one of the drivers of a company's decision to go one way or another may actually, unfortunately, be driven by the reality of having limited options due to how many science and ML engineers that they have. So in the case where ML expertise is quite limited, then you might be limited to only an option of having a very centralized team that must be distributed amongst all the rest of your teams. As for if you have enough resources to have your choice of any of the above, I think that that any of these can work, albeit there's certain anti-patterns to watch out for. One anti-pattern that is important to watch out for if you have some sort of a centralized approach that gets distributed to the teams is there can often be risk of potential desynchronization of understanding of the model and the needs and the risks in particular of the model from those who have actually built it and have deployed it to that team, both in terms of the engineering operational risks as well as the science and customer experience risks that are associated with that. I've seen, I've experienced this kind of anti-pattern of kind of kicking things over the fence, and then the receiving team gets more or less of a black box that they put into production and kind of assume that the model is kind of the gold standard and that it's static over time. So for example, they are not paying adequate attention to data drift and accuracy monitoring and things like that.
You touched on two things that both Rahul and Nikon said. Rahul with the importance of monitoring, and I think Nikon, you said it with, hey, here's a Python code, just do something with it. Go ahead and make this thing good. Okay, wonderful, thank you. Rahul, what do you think? Is there a structure that works, and where does data engineering and DevOps fit into this?
Yeah, I don't think so. There is one right answer to these things. I think a lot of it is driven by the culture of the company, and I've seen both multiple ways how companies have deployed it and have failed miserably in their efforts. So for example, right, you've seen a lot of engineering culture-based, product-based companies tend to have data scientists embedded as part of the product teams, and they're not centralizing those teams, right? And that tends to work really well because then you have one single functional team that tends to be working around the initiatives for that product, and you're not dependent on a central team.
To clarify, Rahul, do these teams talk to each other or no? They're just embedded within their.
It's just embedded within. So you're duplicating stuff, but you're not. So the downside is, right, you're creating multiple, you're not centralizing MLOps, you're not centralizing DevOps and other functions, which could probably run as a good shared service. However, I've seen a lot of companies which are actually centralized, right? Hub and spoke ML teams, a lot of our clients, and prior to Innodata, where they've seen a lot of work with large enterprises. They have this hub and spoke model, centralized AI ML teams. The challenge with that is you're always selling to the business unit, right? You're always trying to sell into a business unit. You're trying to convince the business unit to do it. And all great ideas don't always get implemented because there is so much of change management and so much of pushback that these central teams get, which becomes hard for harder problems to be solved, and then you tend to go for the lowest common denominator because the central hub teams need to show their value, and when you have to show your value, you're going for the easiest things to be solved for, and I think it inhibits a lot of creativity and the value that could be created. So I think, again, these are hard cultural, organizational issues to be dealt with.
Got it. Some of those you're seeing the con in each pro of some of the ones we discussed. Nikon, anything to add?
Yeah, I think it's really interesting. A lot of what Rahul said really resonates with me, and I think Daniel has also good points here. First of all, I don't think there is a clear-cut solution. It's really organization specific. And kind of my operational principle is focus on people's strengths. Look what you have on the ground, look who's available. In some cases, I've seen you have a developer who is really good, he's a production developer. He's a little bit interested in machine learning. Those are good people. They can deploy something into production. And so that you should empower them. You should not try to put roadblocks in their ways. Of course, they do need mentorship and education. And that's where you partner them with a machine learning engineer or someone who is more experienced. And those people will then explain you how to deal with privacy and fairness and incorporate new things or avoid overfitting. And then once you have that kind of partnership between a production engineer and like a mentor, someone who has been doing it for a while, then you can have the infra teams come in and say, okay, look, we're going to simplify things for you. We're going to create a machine learning experience where things are easy, deployment is easy, production is easy. More and more people will participate in that, like the business leaders themselves, not just the production engineer. And the final part of this is, of course, the automation. That's when you start building the automation where the production engineer doesn't need to do anything individually and manually. And so it kind of closes the loop beautifully.
Wonderful. And just to cap off for everyone here, the last part of this question, it also kind of leads into our next one. Might have missed where the DevOps and data engineering folks sort of fit into this. Do we see, and I'm naturally thinking this is going to be a it depends answer too, but just curious what you guys think. Do data engineers and DevOps, are these teams separate from your core data science team that's building these models, or are they apart? Nico, I'm just going to go back to you just because I liked what you said about having all these folks sort of co-mentor, collaborate with each other. They can reinforce each other's skills. I just want to pass to you. So I instinctively want to say that you think it's going to be embedded. They're all embedded together, but go ahead. What do you?
Yeah, I think the real trick is, I think that's what we are kind of rediscovering is the focus on the machine learning experience, because it really solves all the problems. You have the machine learning experience that's simplified, and suddenly data scientists and DevOps can operate in the same realm and they kind of speak the same language, right? You have the production engineers, and the productization becomes much easier because you've created this unified experience. You have these issues with privacy that kind of now, instead of like popping up all the time in waves, they're kind of removed from the customer and the machine learning participant. On the other hand, the issues with fairness are kind of monitored and alerted with suggestions on how to solve those things. I think the trick is really when you create a machine learning experience, more and more of this kind of edge participants go into the middle and participate in the development of machine learning.
Yeah, wonderful. Rahul?
Yeah, I agree with a lot of what Nikon said. Again, I like to have our data engineering teams and the DevOps and the MLOps all together commingled. But I think what's really important is the governance mechanism and what kind of a governance process are you following. We tend to do a lot of design thinking and use design thinking as a way of ensuring we're bringing all the stakeholders across the business together. So, for example, when you're deploying an ML model, right, and you need the UX guy to be aware of and the product guy to be aware of what kind of changes are going to fall, or should you be making a UX change because you've just added another field? I mean, those kinds of things tend to get lost sometimes, and I think so having the ability for DevOps, MLOps, in data engineering, data scientists all together, I think first it gives you career paths and people can move, and you allow the mentoring of different resources, because ML talent is scarce. It's really hard to find all of these skill sets. So I think ability to have them together and drive and mentoring is very important. But just from a product perspective, I like to focus on more on the process, right? You could use any of these processes, but a good process will drive better experience.
Yeah, and that's a very good point. I think we're leaving out some key folks here, which is the product folks, the business analysts, the stakeholders to, I guess, also be along for the ride the entire way, not just sort of tell the team what to do, they disappear for 6 months, and then, you know, they're just left out of the loop. Daniel, anything else you'd like to add?
Yeah, I agree with a lot of what's been discussed so far, and probably the big takeaway that I would leave on this particular question is that of trying to avoid as much as possible the anti-pattern of siloing. So in particular, teams that are scientists that are siloed from the engineers, scientists that are local within your company that are siloed from the science community throughout the rest of the company. There's a lot of opportunity for communication and sharing of tooling, sharing of knowledge, sharing of mentorship, and continual feedback from the various members that are involved across the entire production chain to make sure that we're always looking at ways of improving our operational standards for not just thinking in terms of, for example, scientists thinking in terms of the science corner of development, but thinking more end-to-end based on the feedback that they get from the deployment engineers as well. And very much likewise with the engineers, with the product managers, really trying to facilitate communication and sharing of tools and resources.
Yeah, I just to add my 2 cents and agree with everything everyone says. I beat this analogy to death, but it's one of my favorites, mostly because I'm a Star Trek fan. But so DJ Patel, who was, or who is, well, I'm sorry, I meant that in like in a corporeal sense, but he was formerly the chief US data scientist for the US government. And he had this podcast one time, this interview, and he said, you know, if you look at the Enterprise, like Star Trek, you know, Spock, who's the smartest person on Starfleet, he's not just in a back office room somewhere. He's down with the away team, he's firing his phasers, he's on the bridge. He's constantly there, you know, giving advice to the captain. And in a lot of places in corporate America, these folks are siloed off into the back office somewhere. They're usually an afterthought. So bringing sort of these, you know, smart data science analytics folks along for the ride, really just keeping everybody along for the ride if possible for whatever initiative you're working on is the best way, I think. Seems like we got a good amount of consensus on that here. All right, let's move on to the next question here. And we've talked about a lot of different challenges. Some organization level, you know, problems in organizations, problems in, problem with structure, problem with siloing, proper tools to use. I've also heard some things at a, I would say, systemic level. There's issues with the AI ecosystem generally. There's maybe lack of data availability, lack of talent. Maybe the data you have is biased. I've even seen recently concerns about the environmental footprint of all these nice AI deep learning models we're running. Just might be hard to put it into one, just or pick one, but if you could pick one that you think if sort of gotten rid of, you could wish it away, and it would boost AI adoption or production capabilities or even trust in AI, what do you think that would be? Rahul, I don't think I ever started with you. I apologize. Let's go with you first.
It's all right. I would pick executive sponsorship. I think to me, the number one thing that will move the needle is executive sponsorship across from the top all the way to the down, right? I mean, it is a hard journey. It is not an easy journey. You will not see results on day one, month 3, month 6, month 12. It's a long journey, and if the executives don't have the willpower and the belief that it will drive fundamental reinvention of their business, I think these things will only incrementally make a difference. They will not be transformative. So I would vote for executive sponsorship.
That's a good one, and I'm just going to add mostly because it's kind of related to mine. Sorry, I'm selfish, but it's I think sometimes also executives or leaders, they think AI is almost going to kind of solve not everything, but like, hey, this is the biggest problem I can think of. Throw AI at it and it's going to get better. And I think that's the expectation. But you just said, right, it's like, it's incremental investments. There's time involved. And also maybe that's not the best way to do it. You maybe go after low hanging fruits first, get some quick wins out of the way so you don't suck all the enthusiasm out of whatever initiative you're trying to do. Daniel, let's go with you.
Yeah, sounds great. So absolutely, in terms of empowering your productionalization capabilities in AI, you want to think in terms of best practices. Best practices, however, are going to be superseded by more structured approaches that you build into your organization and build into your production process. But even more superseding that, I'd absolutely encourage keeping abreast of all of the new tooling that is coming out to address specific anti-patterns that are reoccurring in the production process. So AI is still new. AI is still evolving very quickly. However, we're getting to a point in the industry where we have very common anti-patterns that are being identified and specific tooling being addressed to tackle those. And the more that you can encourage teams to embrace those tools, they can really cut down on their production costs tremendously. And beyond AWS SageMaker, there's tons of other tools that are chipping away at that problem as well. So there's absolutely tooling out there to really empower your teams.
Awesome. So find the tool that's going to work for you. Nikon, what do you think?
Yeah, I mean, this totally resonates. I think there are even papers in machine learning called machine learning anti-patterns. I also agree with Rahul that executive sponsorship is the key here. My perspective on this is, I think it's really all about machine learning experience. And what it does is it allows you to have all these different participants and diversity in machine learning development, right? Business leaders, development, production engineers, machine learning engineers. And I think the real output that I see is a transparency in machine learning that has never been there before. Like I would almost compare it like to some sort of like lingua franca, where people can suddenly talk to each other and understand each other when they talk about machine learning. And one of the key outputs of this is they will be able to articulate and have a discussion about business risks. None of the machine learning is going to be perfect, right? It's going to have false positives and false negatives. They all have costs to them. And in the past, it was really difficult to have a conversation with all the participants, right? Like I give you an example. You deployed a machine learning product. You have two models. One of them really underperforms on one gender. The other one underperforms on another gender. How do you have this conversation? How do you solve this dilemma? Right now, it's almost impossible because none of us have a common language. We spend days talking about it, and that's why we avoid talking about it, because it's so really difficult for us. We need this common language, and that's what I'm looking for.
Do you think some of that can be mitigated either by, is it a educate the general population sort of approach, or is it no, we need to develop some technology or visibility into these AI models to help drive the conversation, like why they're making decisions? What do you think?
No, this is absolutely the right question. I don't think I have the answer for that. I know from my personal experience over the couple of years I worked at different companies, it takes you months to explain to business executives what is happening with production models. Like I give you an example. I worked on Alexa voice shopping, and from time to time we had incidents where there was a noise, there was a dog barking, and somebody got 1,000 golf balls delivered to their house. We had to fly immediately to Seattle and explain it to all the Amazon executive what just happened and why there was a mistake in production. I think there is a big problem. Even really smart people don't understand it. Communicating it to the public, that's even more difficult.
Okay, wonderful. Thank you. I think we're coming up a little bit on time. I don't know if we got time for just one more, but let's make it brief. I want to leave the audience with something about like a personal experience or a personal lesson you can give them on either being successful in AI or just successful in life, just something to connect it back to you guys. Let's see, I'll go first. I'm going to go with, I've been just having a lot of conversations. I've been having a lot of conversations lately with up-and-coming, folks coming out of education. They want to know where to take a career. And for some reason, they're very trepidatious about sort of leading people. They think to be a leader, they got to lead people. I guess my bit of advice is there is leadership opportunities also in thought leadership as well. So if you're, trepidatious about leading people, you don't need to be successful necessarily in that. You can also be a thought leader. Nikon, since I picked on you first time, go ahead.
Yeah, actually, I have a very strong life lesson that I've been serving me very well, which is try to avoid all kind of the sexy and the popular topics like 3D printing, personalized medicine, all of those things that are in the media. Avoid all of that and focus on the things that are kind of really impactful, but maybe even kind of boring. Like I worked on insurance for a long time. It was a very successful. Cybersecurity. Right now I'm working on data, and it is an incredibly important work. I think this is how you really become successful, if you focus on the things that don't have the glamour, but are actually really impactful.
Very impactful. That's good advice. Daniel, go for it.
Yeah, for the scientists out there, big tip is just to continue learning, continue lifelong learning. ML and AI over the past 9 years that we've seen have been an absolute explosion of knowledge that has been just an enormous fount of new techniques and technologies coming out on a monthly, almost on a weekly basis. And to keep up with it, you just have to continue learning. Read those white papers, those archive tabs open that you have in your browser that you've been ignoring. Go back and check them out, take the time, and always continue learning.
Rahul?
Yeah, the product manager in me, fail fast, experiment, really go get a lot of feedback from your prospective customers, iterate very quickly, learn, solve the MVP problem. Like, don't skip on getting feedback from your customers. Don't build sexy products or sexy models because you think it is great, but really try to solve the problem and get feedback from your customers, and focus on working with your customers to build your product from an MVP perspective, not because you think it is going to work or one customer feels it's going to work, but really work with plethora of similar customers and find that product market fit sooner than later.
Wonderful. And I think that wraps up for the panel. Thank you all very much.
Thank you.
Wow, thank you. Oh, that was awesome. A special thank you to all of our panelists, and a very special thank you to Arya for moderating and keeping us on track. This has been awesome, and I know this virtual audience is going wild with virtual applause. We really appreciate you all sharing your perspectives with us here today. For the audience, it's time for you to make your way to your next session. Along the way, make sure you accept your connection request and take some time to check out our amazing exhibits. Thanks so much, and we'll see you around.
Thanks, guys.